Hello YouTube, my name is Crumb or Glim for the win. In today's YouTube video, I decided to go on ahead and do some cheating tutorials within Counter-Strike. And in today's YouTube video, I'll be showing you guys how to make a glow ESP. This is completely internal and writes to memory, so be cautious whenever using this because it will get you banned. This is completely just for educational video, so you can learn how to do this on your own. So going ahead and run this to give you an example. There it is. Alright, so with that, let's go ahead and get into the video. Okay, so the first thing you're going to want for this script is you're going to want to open a new Notepad++ file. We want to call it glow.py. And then from here, we're going to go ahead and always first import our necessary modules. So we'll start with struct, time, and random. Now, struct is going to provide us functions to convert between Python values and C structures. This is going to be used for memory read and writing. And then we have time for sleeping intervals, and random to add randomness so that we can hopefully defeat detection at least a little bit, even though it's not really going to do much. Okay, and then the next what we're going to do is we're going to import pymem. And if you haven't heard of pymem before, then this may not be a video for you. It is a library that also is used to read and write memory for external processes, and it's going to be used to interact with CS2. So now we're going to want to add our offsets. So we're going to do class offsets, and then in here we have, I think it's 9 offsets that we're going to want to use. So we'll go on ahead and grab those. So we're going to go to the A2X dumper right here and go into client.dll.json. Alright, and then from here we are going to go and look for the DW local player pawn, which is the offset to the local player's pawn address. So we're going to do DW local, it might not be in here, it might be in offsets.json, wherever that is. Right, no, wrong one, right here. We do DW local player pawn, and now this is what we want right here. So we're going to copy this and bring it back into here, and then we'll do our value, which, what was it, right here. Now we have the offset for that done. We're going to do DW entity list, so we're going to search entity list, there it is, and we're just going to do the same thing for all of these. I'm going to go ahead and speed through this process. Next is m_iteamnum, which for this one we'll need to go back into client DLL. There we go. It's not wanting me to copy that for some reason. And 995. Okay, now we need our mh player pawn. Right there. We're going ahead and, okay, whatever. Grab that. Next is our live state, and I'll explain what all these are for after I write them down here. And then we need glow, and then glow color override. Right there. Okay, and now we need m_b glowing. 81. I don't know why it doesn't want to just copy it for me. Okay, now glow type. So we do m_I glow type right here, glow type. There it goes. And what's value? 48. Okay. So our local player pawn, that is for our local player. The entity list is for the list of entities, the other players, which is classified as an entity. And then the iTeam number is the offset to the player's team members. H player pawn is the offset to the player pawn handle. Live state is the offset to check if the entity is alive or dead. Glow right here is going to be the base offset to the glow object within an entity. And then glow color override is to override the glow color. We can change it to different colors. And then glowing is to enable or disable the glowing. And then iGlow type is the offset to set the glow type or style. Okay. Now we're going to want a main class, or really our only class. We'll call it CS2 Glow Manager, just like that. And now in here we're going to want to put an init, and then we'll do self process name equals cs2.exe, and then module name equals client.dll, just like that. Now we need to do self.pm. This will be a Pymon thing right here. So we do Pymon, and then we do process name. That's going to attach the CS2 process's name right here. Okay. And now we need to get the base address of the client.dll, which is going to be used to calculate all entity related offsets. So we do self.client underscore base equals next, and then in here we do m.lp base of DLL for m in self.pm.list underscore modules, and then we do if m.name.lower equals module name.lower, just like that. And now we need to take out one of those and then do comma none and then put it right there. Okay. And now we need to do if not self.client underscore base. So if it fails to get client.dll, or if it wasn't found, we're going to do an exception. So raise exception. Failed to find client.dll module base. Yeah. No. Sorry about that. Okay, and so now we have this. We're going to want to make another function. This would be a helper function that's going to read the memory at an address within a specific format, for example, like a 64-bit pointer. So we'll do define read self, comma address, comma fmt, and then we do size equals struct dot calc size, and then fmt right here. That way we can calculate the size of the type, and then we do data equals self.pm.read underscore bytes, and then we do address and size. This is going to tell us and read the raw bytes. Now we need to return struct.unpack, and then we do fmt data, and then we set to 0. Okay, that's going to unpack and return the value. Now we need a helper function to write an assigned integer to memory at a given address. So we do define underscore write underscore u self address val. Then we do self.pm.write bytes address struct.pack, and then in here we're going to put I comma val, and then we do 4, just like that. That's going to pack value and write 4 bytes. Okay, so now we need to go on ahead and create another helper function that's going to convert RGBA values to ARGB, which is going to be a 32-bit integer. It's going to be used by the glow. So we're going to do define underscore to ARGB self comma R comma G comma B comma A. Okay, and now we go clamp equals lambda x max 0 comma min. Okay, then we do 1 comma x. That's going to clamp the input values between 0 and 1. And now we do r comma g comma b comma a equals int clamp C times 255, and then we do 4C in R, comma G, comma B, comma A. And then we have to end it with a bracket. Okay, that's going to scale from 0 to 255, and then we do return A to 24, and then we do R to 16, and then we do G 8, and then we write B. That's going to combine it into a single ARGB value, and now we need to retrieve the team number of the local player. So we'll do define underscore get local team self, then we do local pawn. Right here we're going to do local underscore pawn equals self dot underscore read. And we'll do self dot client underscore base plus offsets dot dw local player pawn right there, and then we'll type a Q right here to get the local player pawn pointer. Now we need to return none if local pawn equals 0, else self dot underscore read local pawn plus offsets dot m underscore I team num. Okay, and then that's going to read the team number or return none. We need to write I right here, just like that. All right, and now we need to update the glow. So for this part, we are going to give it some space here. We're going to write define update glow and then self, and then we write local equals self dot underscore read self dot client base plus offsets dot dw local player pawn comma q. That again is going to get the local player pawn, and now we need to get the base of the entity list. So we'll do entity list equals self dot underscore read self dot client base plus offsets dot dw entity list. Okay, and now we want a Q in here again to get the base of the entity list, and now we do our team. So we'll do team local equals self dot underscore get local team, just like that. That's going to get the team number of the local player. And then we'll do if not local or not entity list or team local is none. Alright, so abort if something is wrong or invalid. So we'll do return. And now we need to loop through the entities, which the maximum of entities that there can be is 64 slots. So we'll do 4i in range, and then right here we'll type 64, and then do entry equals self dot underscore read entity list plus ox10 comma q. That's going to be the first level entry pointer in the entity list, and then we'll write if not entry continue. Okay, and now we need to get the controller, get the player controller from the entity. So we'll do controller equals self dot underscore read, and then we'll do entry plus I times ox78 comma q, just like that. And now we need to do if not controller then continue. Okay, and now we need to get our pawn handle, so we'll do pawn underscore handle equals self dot underscore read controller plus offsets dot m underscore h player pawn, and then we'll type I right here to get the player pawn handle, and then if not, pawn handle continue. Now we need to get the pointer to correct the entity list page. So we'll do entry2 equals self.read entity list plus ox8 times, and then in here we will type pawn handle and ox7 fff, and then we'll do 9, just like that, and then actually we do plus ox10 comma q. There we go. And now we do if not entry to continue. Okay. And now we need to get the final pawn pointer using entry2 page and the slot index. So we'll do pawn equals self dot underscore read entry2 plus ox78, and then we'll do multiply pawn handle and ox7 fff. No, we want to do ox1 ff, like that, and then we do comma q, just like that, and then we do if not pawn or pawn equals local, and then we skip if it's an invalid or a local player. We do continue. Alright, now we do is team equals self dot read pawn plus offsets dot m I team I equals team local. Alright, so that checks if the entity is on the same team. And now we need to do color equals 1, 0, 0, 1, and then we'll do if is team else, and then we'll do 0, 0, 1, 1. Alright, so this is going to choose color red for teammates and then blue for enemies. Alright, now we need to do glow equals pawn plus offsets dot m underscore glow, glowing actually. No, we want glow. We want glow right here. So then that's going to be the base glow structure for the game, or for the pawn, and then we do self dot underscore right u, and then we'll do glow plus offsets dot m underscore b glowing 1. So that's going to enable glowing, and then we'll do self dot underscore right u. We'll do glow plus offsets dot m underscore I glow type, and then we'll do self dot underscore right u glow plus offsets dot m glow color override. And now we want self dot underscore 2 argb, and then we'll do times color, just like that. It's going to apply the glow color. And now we need our main function right here, which is going to be define run self, and then we'll do try while true. Oh shit. While true, self.update glow. It's going to refresh the glow data for all entities, and then we can, this is where we'll use random right here. We're going to do time.sleep, and then we'll do plus random dot uniform, and then in here we'll type 0,005. Alright, so that's going to make it sleep anywhere between 0.01 and 0.05. Meant to do that. Okay, and now we want an exception in here, so we'll go back, not forward, go back. We'll do except keyboard interrupt, and then this is going to handle Control+C cleanly. So then we'll do, we're going to put a print statement in here, type in exiting, right? And then we're going to do self.pm.close process, because whenever we're doing this, it's going to be PyMin holding the process, not exactly Python. So now we do if name equals main, then we're going to do cs2 glow manager dot run, just like that. So that creates the instance and starts the glow. So let's go ahead and run this and see where I made any mistypes at. Going ahead and run. Yeah, definitely a mistype in there. So we're going to open it up in CMD to debug our issue here in line 34. So we go back in here to line 34. Where's it at? Right here. So we have RGBA equals int clamp C times 2 to 55 4C in RGBA. What did I do wrong? I'm gonna pause this and look into it more. Okay, easy fix right here where it says this. I got my spaces, that's all. So we're going ahead and run it again. So I just put a stupid mistype right here. I don't know how I missed that, but now we have another concern right here for line 62. It was never closed. So, yeah. Oh, I really don't want to do that. And then in main right here. Import struct. What did I put? Yeah. What line is this on? 62? Okay, look back on line 62 right here. Okay, so on line 62 right here, we want to do this. Now we get another message on line 76 right here. Wow. So for this right here, we forgot nothing more than just a value to set. So now we run again. So it's running. Oh, it's running. Yeah, there you go, guys. That's how you make that. So this is a short little video decided to make, run it up really quickly. Sorry for some of my mistypes. If you couldn't tell, I was reading it from the original script that I made from here. I didn't want to just do it all by the top of my noggin. But I hope this guys helped you learn. I hope you enjoyed the video. And if you did, please like and subscribe. Okay guys, so I'm actually back to show you something very interesting that I should have shared earlier in the video that I did know about, but I didn't think about mentioning this. There will be a screenshot right here that shows what I'm talking about, and I might include the post where I found this at, but it's on Unknown Cheats. So right here on glow type, there is different values that we can set this to for what we want it to do, right? So 0 is going to be never, 1 is going to be whenever it's being used, 2 is going to be when being looked at, and 3 is constantly. So we'll go ahead and show you what this looks like. So we'll just go ahead and set this to 0, and then go into here and run it. Now it's running. So now it's just always on no matter what. Okay, same as if it was at 1, which we're going ahead and set that to 1 there, and then run it. Always on, right? And now we can set it to 2 for whenever being looked at. And then we go ahead and do that. So now it'll only do it for the people that you're looking at, which is pretty cool. So yeah. Next is 3, which is going to be constantly the same as 0 or 1. Now, you might be wondering why does this matter? Why are you showing me this? Well, because it's just something that you could use to, further your reverse engineering. You could figure some other stuff to do with this that I won't really be explaining in this video because I don't know what you could do with it. But yeah, so like for example, I do know for example that if you do it for when being looked at, then you could use this as a sort of visibility check to where it's not going to be a very good visibility check, but you could use it as one so that it only does it for the people that you're looking at, right? For an aimbot or something. But with that, I'm going to go ahead and end the video from here. And I hope you guys like this. I hope I'm being informative enough. And if you want to see any other videos on this, on Counter-Strike, please leave a like and subscribe. Comment what you would like to see, and I'll do my best to make a video on it, as I have made a video on a lot of different features in Counter-Strike. I've made a lot of, not video, but a lot of different projects in Counter-Strike. And I'm constantly learning just like everybody else is. So again, like and subscribe, and I'll see you in the next one. Peace.